First one is introduction. How are the various articles and materials shown in the picture measured? Vegetable is measured in kilogram, cloth measured in meter, time is measured in second, milk is measured in liter. Okay, next, in a day-to-day life we measure many things such as weight of fruits, vegetables, food grains, volume of liquids, temperature of the body, speed of the vehicle, etc. Then quantities such as mass, weight, distance, temperature and volume are called physical quantities. Next, a value and unit are used to express the magnitude of a physical quantity. For example, Suresh walks 2 km every day. In this example, 2 is the value and kilometer is the unit used to express the magnitude of distance, which is physical quantity. Next, fundamental and derived quantities. Generally, physical quantities are classified into two types, namely fundamental quantities, another one is derived quantities. Fundamental quantities, a set of physical quantities which cannot be expressed in terms of any other quantities are known as fundamental quantities. Their corresponding units are called fundamental units. Here there are 7 fundamental quantities in SI unit. Okay, first one is length, meter, mass, kilogram. Next, time, second, temperature, Kelvin, electric current, ampere, amount of substance, mole. Next, luminous intensity, candela, like that. Okay, next, derived quantities, all other physical quantities which can be obtained by multiplying, dividing or mathematically combining the fundamental quantities are known as derived quantities. Their corresponding units are called derived units. Okay, some of the derived quantities are there in table 1.1. Listen carefully. Table 1.1, area, length into breadth, that is meter into meter, square meter. Volume, length into breadth into height, that is cubic meter. Speed, distance per time, that is meter per second or meter second per -1. Electric charge, electric current into time, or A into S or coulomb. Density, mass by volume, that is kilogram per meter cube or kilogram meter power minus. Next, area. Area is measure of how much space there on flat surface. The area of plot land is derived by multiplying the length and breadth. Area is equal to length into breadth. The unit of area is meter into meter, that is square meter, that is meter square. Next, area is derived quantity as we obtained by multiplying twice of the fundamental physical quantity length. Next, the square meter is the area enclosed inside a square of one side 1 meter. Next, problem 1.1. What is the area of 10 squares each of the side of 1 meter? How we can calculate area of side equal to side into side, 1 meter into 1 meter, 1 meter square or 1 square meter. Next, area of 10 squares, 1 square meter into 10, so totally 10 square meter. Next, even though area is given in square meter, the surface need not to be in square shape. Okay, next. Next, area of regularly shaped figures. The area of regularly shaped figures can be calculated using the relevant formula. In the table 1.2, formula used to calculate the area of certain regularly shaped figures are given. Okay, next problem 1.2. Find the area of the following regular shaped figure. Take pi is equal to 22/7. First question, a rectangle whose length is 12 meter, breadth is 4 meter. Second question, a circle whose radius is 7 meter. Third question, a triangle base is 6 meter, height is 8 meter. Okay, first question, area of rectangle, okay, length into breadth 12 into 12 fours are 48 square meter. Next, area of circle, pi r square 22 into 7, 7 sevens are 154, so 7 7 get cancelled, so 22 sevens are 154 meter square. Next, some area of some regularly shaped square a into a, so side into side a squared. அடுத்து rectangle l into b, so lb, breadth into breadth. Next, circle r, pi into radius square, radius is r, pi into r square, so pi r square. Next, triangle, this is half into base into height, half into bh is equal to half bh. Okay, next, one more question is there, area of triangle, half into base into height, half into 6 8s are, okay, 1 2s are 2, 3 2s are 6, so totally 24 meter square. Next, area of irregularly shaped figures. In our daily life we encounter many irregular shaped figures like leaves, maps, stickers of stars, flowers, peacock feather, etc. The area of such irregularly shaped figures cannot be calculated by using any formula. Next, how can we find the area of this irregularly shaped object? We can find the area of these figures with the help of graph sheet. Okay, next, the following activity shows how to find the area of irregularly shaped plane figures. Okay, the graphical method explained above can be find the area of regularly shaped figure also. In the case of square, rectangle, this method gives area accurately. Here, activity 1, listen carefully. Here, activity 1, take a leaf from any one of the tree in your neighborhood, place the leaf on a graph sheet and draw the outline of the leaf with pencil. Okay, remove the leaf, you can see outline of the leaf on the graph sheet. Okay, like this. Okay, now count the number of whole square enclosed within the outline of the leaf, take it be m. Then count the number of square that more than half, take it as n. Next, count the number of squares which are half of a whole square, note it to be p. Next, finally count the number of squares are less than half, it is q. So m is equal to n equal to p equal to q equal to. From that, approximate area of leaf can be calculated by the following formula: m into 3/4n 1/2p 1/4q square centimeter. So the area of the leaf is equal to dash. The formula can be used to calculate the any irregularly shaped plane figures. Okay, is it clear? Okay. Now time for material reading. First one, very short answer. Name some of the derived quantities, that is area, volume, density, force, pressure. These are the derived quantities. Next, give one value of 1 light year. 1 light year is equal to 9.46 into 10 power 15 meter. Next, write down the formula used to find the volume of cylinder. Volume of cylinder is equal to pi r squared h cubic unit. Next, give the formula to find the density of the object. Density is equal to mass by volume. Next, Next, listen carefully. Name the liquid which can be iron ball sinks. Okay, iron ball sinks in water except mercury. Okay, name the units used to measure the distance between celestial object, that is astronomical units, a light year. Next, what is the density of gold? 19,300 kilogram meter cube. Okay. Next, short answer. What are derived quantities? The physical quantity which can be obtained by multiplying, dividing, or mathematically combining the fundamental quantities are known as derived quantities. Is it clear? Okay. Next, one important question. Distinguish between volume of liquid and capacity of a container. Volume of liquid, the amount of space occupied by a liquid at rest. The amount of space available in a container that can be filled with container. Okay. Next, it is measured in the cubic, it is measured in liter, gallon, pound, etc. Okay. Next, density of the object. The density of the object is equal to the mass of divided by the total volume. Density is equal to mass by volume. Next, one important 5 mark, that is describe the graphical method to find the area of irregularly shaped figure. Place the leaf graph sheet and draw the outline of the leaf with the pencil. Remove the leaf, we can see the outline of the graph sheet. Okay. Next, now count the number of whole square enclosed within the outline of the leaf, take it to be m. Next, then count the number of squares are more than half, take it as n. Next, count the number of squares which are half of a whole square, note it to be p. Finally, count the numbers square are less than half, let it be q. M equal to n equal to p equal to q. Now approximate area of leaf can be calculated by using the formula m plus 3 by 4 n in plus 1 by 2 p plus 1 by 4 q square. Area of the leaf equal to dash. That's all. Thank you.